We will continue again with this example. Consider 2 moles of a monatomic ideal gas that is taken from state A to state B by 2 different pathways. Okay, so here you have the first pathway from step 1 to step 2 and reach to state B. Okay, and then the second pathway is from using step 3 and step 4 to state B, as shown in this figure 1. Okay, then question 1. 1A, sketch a PV diagram to describe the process. So here, so you need to plot the PV graph. Okay, so this is your P, this is a V, and here you can see the pressure is 2 atm, 2 atm, 1 atm, 1 atm. So this is 1 atm, this is 2 atm. Okay, so and this is volume in liter. So the volume is 10 liters, 30 liters, 30 liters, 10 liters. So here will be 10 liters and this is 30 liters. Okay. So now we want to see for the state 1 BAVA. So it's 2 atm. Okay, 2 atm and 10 liters. So this is A. Okay. Then BC. So this is 2 atm and 30 liters. So this is C. Okay. So this is pathway 1 and this is pathway 1. Okay, and then the other step is VB PV 1 atm 30 liters. Okay, so this is step 1. Okay, and then this is step 2. Okay, then for step 3, from here to 1 atm 10 liters. Okay, so this is step 3, and step 4 30 liters and 1 atm. Okay, so this is the step 4. Okay, so this is the answer for the part A. And part B, you need to calculate. You need to calculate Q, W, delta U, delta H for each step. Okay, so now we calculate first for the step 1. Okay, so for the step 1, this is a isobaric process. Okay, isobaric process at 2 atm, where you can see the expansion from 10 liters to 30 liters. So this is a expansion process. So W equals to minus P ext Vc minus Va. Okay, so V2 minus V1. Then this equals to minus P is 2 atm and Vc is 30 minus 10 liters. Okay, so so you will get minus 40 atm, and this is liters. So here I will write first 1 atm liters. If you want to convert to Pascal meter cube, So 1 atm 325 Pascal liters. So this is 10 minus 3 meter cube. Okay. So atm liter liter. Okay. So that means 1 atm liter equals to 101.325 PA meter cube. Okay, so this one you just multiply with 101.325 PA M3. Okay, so this is per, okay, so this is per ATM liter. Okay, so cancel off, cancel off. So you will get negative 4053 Pascal meter cube. This is Joule. Okay, so once you find the W, so you can find also here the what we call the temperature. Okay, so the temperature A here, so you can use a PV and RT to calculate. So so TA is 121.88 Kelvin, and for here the TC P, PV, and okay, so let me check. So this is 365.63 Kelvin. Okay, so you need to check carefully. 2 times 30 equals divide by NR. Okay, yeah, correct. And now here this is for TB. Okay, so TB equals to NRPE. So this is 182.82 Kelvin. This is TD. TD is 1. So this is 60.94 Kelvin. Okay. So once you find the W, then you can calculate the delta U. Okay, so the delta U equals to N CVM TC minus TA. Okay, so N is 2 times CVM. CVM. So this is monatomic ideal gas. So this is 1.5 R. Okay, 1.5 R times TC minus TA. So 365.63 minus 121.88. So it's 243.75. Okay. So please you write down all the units here. Okay, because I need to save some space for the calculation. So delta U is 6079.61 joule. Okay, and for the delta H equals to N CPM TC minus TA. Okay, so if you calculate, then you will get 10132.69 joule. Okay, and then you need to find out the Q. Okay, so Q, since this is isobaric process, okay, so you can use QP equals to delta H. So this is 10132.69 joule. Or if you want to double confirm, you can use a Q equals to delta U minus W. Okay, so delta U is 6079.61 joule minus W is minus 4053 joule. Okay, so you will get the same answer, 10132.61 joule. Okay, so it's almost the same, the answer. Okay, so this is for the step 1. Now we go to see step 2. Okay, so the step 2, this is constant volume. So the constant volume means this is isochoric process. So the delta U will be, delta V. Delta V equals to 0. Okay, so delta V equals to 0. So the W will be 0 also. Okay, so then you will get delta U equals to Q. Okay, so this is a constant volume, so QV. QV equals to delta U and plus W, so W equals to 0, so we don't write anything. So this equals to NCVM T2 minus T1. So this is a T is T. This is the TB. Okay, so this will be TB minus TC. Okay, so N is 2 times 1.5 times 8.314 times, so TB minus TC is 182.82 minus 365.63. So it will be negative 182.81 Kelvin. Okay, so so this will be negative 4559.64 joule. Okay, next we will calculate the delta H. Okay, so the delta H is NCPM TB minus TC. Okay, so if you calculate, so you'll get negative 7599.41 joule. Okay, so this is the answer for step 2. You have a W, delta U, Q, and delta H. These are the values. And for the step 3, so for the step 3, this is also isochoric process, where the volume is still remains 10 liters. So delta V equals to 0 and W equals to 0. So you follow the same. Okay, so delta U equals to QV equals to NCVM. This is TD minus TA. Okay, so TD minus TA. So this is 2 times 1.5 times 8.314 times TD minus TA, 60.94 minus 1 to 1.88, negative 60.94. Okay, so equals to minus 1519.97 joule. Okay, and for delta H equals to delta NCPM TD minus TA. Okay, so you will get the answer negative 2533.27 joule. Okay, so this is the answer for the step 3. Now we go to see step 4. Okay, so step 4, this is a isobaric process. So isobaric process, W equals to minus P ext V B minus B D. Okay, so minus P is 1 atm, VB is 30 minus 10. So this will be negative 20 liter atm. So you multiply with 101.325 BAM3 L atm. So you cancel off. Then at the end, W equals to negative 2026.5 joule. Okay, then delta U, okay, delta U is NCVM TB minus TD. Okay, so N is 2 times 1.5 times 8.314 times TB. TB is 182.82 minus 60.94. Okay, so here will be 121.88 Kelvin. So here the answer is 3039.93 joule. Okay. Then for delta H NCPM TB minus TD. So if you calculate, you will get 5066.55 joule. Okay, so this is for the step for step 4. Okay, now we'll see part C. Calculate W, Q, delta U, delta H for both pathway. So for pathway 1 equals to step 1 plus step 2. Okay, so for delta H. We see the delta H first. So the delta H is 10132.69 plus delta H step 2 is this. So minus 7599.41. So the answer will be 2533.28 joule. Okay. Delta U. So the delta U for step 1 is 6079.6. Delta U here. So minus 4559.64. 4559. Okay. So the answer is 1519.96 joule. Okay. And for Q, so Q, yeah. Okay, so Q is 10132.69 plus Q step 2, so minus 4559.64. Okay, so this is 5573.05 joule. Then W. So the W step 1 is this value. So negative 4053. Step 2, W is 0. Okay, so it will be negative 4053 joule. Okay, now for the pathway 2 is S3 plus S4. Okay, delta H. So delta H is negative 2533.27 plus 5066.55. So you will get the answer 2533.28 joule. Delta U. So delta U is this value, negative 1519.97. And delta U here is this value, plus 3039.93. So it's 1519.96 joule. Then Q is negative 1519.97. So where is Q? Okay, so since this is an isobaric process, okay, so this is isobaric process. So QP equals to your delta H. Okay, so this is 5066.55 joule. Okay, so your QP is this value, plus 5066.55. So 3546.58 joule. And finally, W. So for W, S3, step 3, 0 plus this value. Okay, so here you will get negative 2026.5 joule. Okay, yeah, it's a bit long, this question. So here you have already calculated Q, W, delta U, delta H for both pathway, pathway 1 and pathway 2. And now the question D, compare and comment on the Q, W, delta U, and delta H obtained for both pathway. So you can see here delta U, delta H. Yeah, you can see this one, delta H, and the delta H for pathway 1, pathway 2, they are similar. Delta H 1519.96. Here also 1519.96. So what does it mean here? So when you see what we call the graph, so you can see this graph. You still remember what we call this state function. So state function, it means it doesn't depend on the path that you take to reach to the final state. So if you use this pathway to reach to this state, and you use this pathway to reach to this state, the final value will be the same. So this is the definition of state function. Okay, so you can see delta H, delta U, they have the same value. So that means that delta U, so that means delta U and delta H, they are state function. Okay, whereas for Q and W, so you can see the Q value is 5573.05, and here Q is the 3546.58. So they are different. And W also negative 4053 joule, and here W is negative 2026.5. So they are different. So that means W and Q, they are non-state function. Okay, so these are the answer. So based on here, when you see the value, they are similar. So that means delta U, delta H, they are state function, and Q and W, they are not state functions since the value, they are not the same. Okay. Okay, now we will continue with the example for this time is thermochemistry. Okay, calculate delta H, delta U at 298 Kelvin and delta H at 378 Kelvin for the reaction C graphite plus H2O gas to CO gas plus H2 gas. Assume all heat capacity to be constant over the temperature range involved. So all the value given here are at 298 Kelvin. So it is given delta H formation and heat capacity at constant pressure for all these substances. Okay, so first you need to find out the delta H at 298 Kelvin. Okay, so for delta H at 298 Kelvin, so since you have already the delta H formation at 298 Kelvin here. Okay, so what you need to do is a summation delta H product minus summation delta H reactants. Okay, so this is delta H for H2 plus delta H CO minus delta H C graphite plus delta H H2O gas. Okay. Then this is a delta F formation. Okay, so and write this. And for H2, this is 0, and this is negative 11053. So this is 0, negative 110.53 minus. So delta HF for graphite is 0. Okay, it's 0. And then this is the value, negative 241.82. Unit is kilojoule per mole. So the answer is 131.29 kilojoule per mole. Okay. So delta U, so you can use delta H, delta U plus delta N gas RT. Okay, so you will get delta U equals to delta H minus delta N gas RT. So delta H is 131.290 joule per mole minus, and this one delta N gas. So you find from here, you only count the substance that exists in gas form. Okay, so for this C graphite, carbon graphite is a solid, so we don't count this. Okay, so 1 mole plus 1 mole minus 1 mole, so this is 2 minus 1. Okay, so here will be 2 minus 1. R is 8.314. This is joule per mole per Kelvin. T is 298 Kelvin. Okay, so you cancel off, and this is a joule per mole. Okay, and this is not in the mole. Okay, so you don't write the mole here. So at the end, you will get the answer. Okay. So you'll get 128.812 kilojoule per mole. Okay, so this is the delta U at 298 Kelvin. So the next step is to calculate delta H at 378 Kelvin. So delta H at 378 Kelvin equals to delta H 298 plus from 298 Kelvin to 378 Cp and dt. Okay, so for this delta H 298, so what does it mean? This is the enthalpy at 298 Kelvin and minus enthalpy at 0 Kelvin. Okay, so if this one delta H 378 means H 378 Kelvin minus H at 0 Kelvin. Okay, so this you can write in this. Okay, so that means that this is from 298 Kelvin minus 0 Kelvin, and then this is 378 Kelvin minus H at 298 Kelvin. Then you can get this delta H at 378 Kelvin. So delta H 298 you have already here. Okay, so this is a delta H 298, but we don't have this. Okay, so how to do this? We need to find out first the CPM for the reaction. So this is a summation of CPM product minus CPM reactant. Okay, so CPM for the product is 29.15 plus this. So 29.14 plus 28.83. So this will be 57.97 minus 8.53 plus 8.53 plus 33.58. So this will be 42.11. So CPM is 15.86 joule per mole per Kelvin. Okay, so now you can replace CPM with 15.86. Okay, so delta H 378 equals to 131290 plus 15.86 times 378 minus 298. Okay, if you integrate, then you will get this this form. So you will get the answer 132.559 kilojoule per mole. Okay, so this is the answer for delta H at 378 Kelvin. Okay, now we will see this example. Assume all gases behave ideally and using the following data obtained at 25 degrees Celsius. So you have 4 equations here with a delta H standard kilojoule per mole. So you calculate delta H and delta U under standard condition for the following reaction. So this 1 and 2. Okay, so now we will work on this question first. So the first thing what you need to do is you can write down the overall reaction OH gas, okay, OH in the gas form and H in the gas form plus O in the gas form. Okay, so for the second thing you need to do is you find out which reaction produce OH gas. So here, okay, so you can see this is at the right side, but here you get it from the right left side. So you need to reverse it. So when you reverse it, then here the positive value it must multiply with a negative. Okay, so you will get half H2 gas plus half O2 gas. So here you will get negative 38.95. Okay. And for the second step here, you need to find the H gas. So which give you H gas? So it's this equation, but this is 2 mole. So you need to divide by 2. Okay, so you will get half H2 gas. And here you get H gas. Okay, so 435.99 divided by 2. So you will get 217.995. Okay, and for the next step is you need to find the O, O gas. Which one gives you O gas? So it's this equation, but here is 2 mole. So you need to divided by 2. Okay, so it will be half O2 gas, and this is O gas. Okay, so 498.34 divided by 2. So you will get 249.17. Okay, so this is your delta H naught kilojoule per mole. Okay, so now this is the most important step is to see whether this is balanced or not. So you cancel off this half H2, half H2, half O2 gas, half O2 gas. So you are left only OH gas, O gas, and H gas. So that means this process is, this equation is correct. So if you total up together, so you will get 428.215 kilojoule per mole. Okay. Now, you need to find out also the delta H naught. Okay. So just now you calculate the delta H. So delta H naught equals to delta U naught plus delta N N gas RT. Okay. So delta U naught equals to delta H naught minus delta N gas RT. So delta H naught is 2428215 minus delta N gas. So here you have a 2 mole gas and here you have a 1 mole gas. So 2 minus 1, R is 8.314, T is 298 Kelvin. So you will get the answer 425.737 kilojoule per mole. Okay, so this is for the part A. So this is the first part. And for the second part, so for the second part, you write down the equation H2O gas, and this is O gas plus 2H gas. Okay, so H2O gas, which one gives you H2O gas? Yes, this equation. Okay, so you write down H2 gas plus half O2 gas to H2O gas. Okay, so this is negative 241.81. Okay, next is O gas. So which one gives you O gas? Yes, this equation. So, but you need to divide by 2. So it will become half O2 gas. Then you'll get O gas. Okay. So 498.34 divided by 2. So it will be 249.17. Okay. Next, you need to find out 2H. So 2H is this equation. So it will be H2 gas, 2H gas. Okay, so this will be 435.99. Okay, now you need to total up together. So But here, still cannot cancel off, okay, because this is half O2. Half O2 is O2. One more of O2. Here you don't have a O2, so you need to find another one which has a O2 and H2O gas also. So it's this equation. So it's from this equation. Okay, so you need to, let me see how. Oh yeah, here you have a H2. You have a H2, H2, okay, 2H2, and this is 1O2, okay. So that means here you must have a 2H2 plus 1 mole of oxygen. So can you find which equation give you this variable? So yeah, it's this equation, okay. So you need to multiply with 2, and then you need to what you call shift the direction. Okay, so it will become 2H2O gas. Okay, so negative, then you put the positive, then 241.81 times 2, so you'll get 483.62. So this is your delta H naught kilojoule per mole. Okay. So the answer is 926.97 kilojoule per mole. Okay. Then you find out delta H, delta U naught is delta H naught minus delta N gas RT. So delta H naught is 926.970 minus delta N gas is 2 plus 1 is 3. 3 minus 1. Okay, so 3 minus 1. So 8.314 T298 Kelvin. So the final answer is 922.015 kilojoule per mole. Okay, so these are the answers. Okay, this is the answer for the delta U. This is for the delta H. Okay, and delta U and delta H. Okay, for these two answers. Okay, so I hope that you can understand all these examples. If you don't understand, then you can replay again and then to do some more revision. Okay, so I think that's all for this video. Thank you very much.